Hi everybody, we are Group 6 and today we are going to share what we did for the Natural Language Processing module assignment. Before we start, these are the members of the group and our respective roles. Social media has grown tremendously in the last few years and has captured millions of users worldwide, with Twitter being one of the most popular social platforms, amassing around 238 million daily active users around the world as of July 2022. With Twitter, users can instantly compose and share messages called tweets and interact with other users. However, with social media having such a widespread influence in our life, if the use of social media is not monitored or the content are not moderated, it can lead to serious consequences. This is because on these platforms, users can hide their real identity behind the account. This enables them to upload hurtful and aggressive comments towards others and not deal with the consequences. Hence, with that in mind, our goal is to build an application using machine learning models to analyze the sentiments of the tweets on Twitter. We crawled a total of 10,763 English tweets using the SNScript library, and some examples of the keywords we use are Wuhan, white trash, hate speech, and Nazi. We labeled them according to opinionated versus non-opinionated, and categorized the sentiments according to negative, neutral, or positive.
The first model that we use is TextBlob. TextBlob is an NLTK-based model trained using common day-to-day words. It supports complex text analysis and operations and is primarily used for sentiment analysis. The sentiment scores are assigned to individual words, and the final sentiment of the tweet is calculated by taking an average of all words in the tweet. Here's the performance for the TextBlob model. We achieve a relatively high accuracy for the subjectivity model of 0.87 with high precision recall on F1 as well. The polarity model did slightly worse with an accuracy of 80%, but with a very high recall of 0.99.
Keras is a Python-based API that aids our approach in using deep learning for classification. Keras is considerably beginner-friendly with ample documentation and tutorials. It is also flexible and designed for fast experimentation, which is helpful for our project. We built the models from scratch to do polarity and subjectivity detection. In order to incorporate the textual data to the models, we use word embeddings. Moving on, different versions of the models with different layers and parameters were carried out and experimented on to obtain the results shown. In general, the Keras models perform well with regards to both subjectivity and polarity detection. For both subjectivity and polarity, the models obtain a relatively high accuracy of about 89% with high precision and recall as well. As such, the F1 score obtained is also high. This could imply that there were only a small proportion of false negatives and false positives generated.
For the last model, BERT-based model was used via the Transformers library. BERT is a popular Transformers model pre-trained on a large corpus of English data. It was pre-trained with masked language modeling and next sentence prediction. Therefore, we chose BERT as it can be used to extract features helpful for downstream tasks such as classification tasks. This table shows an overview of BERT's performance on the test dataset. For subjectivity detection, it did relatively well. However, for polarity task, it performed very badly because it has a low F1 score despite a high accuracy. Overall, the worst performing model is BERT. This might be possibly due to bias towards the majority class for the polarity task, which is the negative label. It might also be due to the type of tokenizer used for the BERT model. It might also be because the BERT parameters were all frozen and the weights were not updated. All in all, there's a need for improvement.
Moving on to our innovations. For our first innovation, we decided to do the racism subtask. Because context matters in any user-generated content, so tweets that might be racist may not actually carry a negative sentiment, and vice versa. In fact, some tweets that are racist can have positive or neutral sentiments, as shown in the 3 examples below. As such, an additional label is needed to determine if the tweet is racist.
One other innovation we focused on was stacking a convolutional neural network on our classification model. In this case, we stacked CNN with BERT. It has shown to reliably increase classification accuracy. In this architecture shown in the figure, the outputs of all transformer encoders are used instead of using the output of the latest transformer encoder, so that the output vectors of each transformer encoder are concatenated, and a matrix is produced. By concatenating these values, a vector is generated which is given as input to a fully connected network. By applying softmax on the input, the classification operation is performed for the polarity task. For opinions and racism subtasks, sigmoid was used instead. To sum up, it is important that user-generated content are monitored and malicious content are filtered out. Having a well-trained and innovative classification model to flag such tweets will be beneficial to the platform in its content moderation process. With this Twitter sentiment analysis application, we strive to develop a safe and welcoming online community for all users, leading to a pleasant experience on the platform.